So the topic of my talk today is a certain sort of metaphysical proclivity, and that is the tendency to equate the fundamental with that that is wholly inexplicable, right? That which is, in other words, brute, right? Wholly lacking in explanation. Now, I don't want to spend a whole lot of time convincing you that this is how philosophers, and metaphysicians in particular, tend to think about the fundamental, but hopefully quotes like the following won't sound unfamiliar to you. So according to Gideon Rosen, a fact is fundamental or brute, if and only if it doesn't obtain in virtue of others. For Ross Cameron, the fundamental or brute truths give us the ultimate foundation for the whole of reality. For Steinvor Anodatier and Tim Crane, the fundamental or brute truths, facts must be facts within physics. And for Uriah Kriegel, micropsychism would need to posit fundamental or brute laws. So in all of these quotes, the word fundamental and the word brute are basically being used as kind of synonyms for each other, right? It's kind of taken that being fundamental and being without any explanation come to the same thing, okay? So that's the view. So let's call this picture of the fundamental brute fundamentalism, or for brevity and kind of for dialectical effect, we could also just call it brutalism. Now, what I want to claim is that for all its familiarity, brutalism seems to be in tension with another doctrine of metaphysics that is, again, also just kind of completely unorthodox, and that is the doctrine of physicalism, right? The view that the actual world is fundamentally physical. And the reason it seems to me to be in tension with physicalism is because it strikes me as being in increasing tension with physics. So in order to kind of make this point right off the bat, I'm just going to quote that book that Steven Weinberg wrote in the 1990s, in which he argued at length that the aim of physics at its most fundamental level is not just to describe the world, but to explain why it is the way that it is. Okay. So this is an ambition that is just completely orthogonal, right? It's just incompatible with, incompatible with the doctrine of brutalism. Now, anybody would be right to be a bit suspicious of the often quite hubristic claims of this chief propagandist of particle physics. But as a metaphysician, I wouldn't want to turn round to Steven Weinberg and tell him what it is a priori that physics is or isn't able to do. Okay, and that's exactly what brutalism seems to be doing, which strikes me as a problem. So what I want to do today is to think about, or at least start to think about, what it would mean to make good on Weinberg's ambition and so explain the fundamental and deny brutalism, therefore. Now, what I'm going to do is I'm going to use quantum field theory as a model of how brutalism might be denied. And now, some of you might be protesting, especially people very closely involved with this project, that, well, we don't think that, this is... makes the project kind of pointless because we don't think that the fundamental level is correctly described by quantum field theory, at least not kind of the normal sort of field theory on flat Minkowski spacetime, because this can't incorporate gravity, it seems, at least not so far. But really what I'm going to do is sort of invite those of you, I don't know anything about quantum gravity frameworks, I'm going to invite those of you who do to think about whether and how the broad metaphysical and methodological morals that I'm going to draw out of quantum field theory with regard to the fundamental are going to generalize there. So I'd love to hear what any of you who know about these things have to say about it. My money's on them actually becoming more pronounced. Okay. And if I have time, I'll maybe right at the end try to do a little bit to diagnose this seeming kind of disconsonance or disconnect between physics and metaphysics with regard to the fundamental, right? Why these seem to be so diametrically opposed. Okay, so let's start off by talking a bit about brutalism. So according to this doctrine, the fundamental is by definition that which is without explanation, that which is brute and inexplicable. Now, I take brutalism to commit to the claim not that, there's some parts of the fundamental level that we can give some explanation for or something like that, but there's some bits that we can't. No, if you're a brutalist, to be fundamental is to be without explanation, and that means every element of the fundamental level has to be wholly lacking in explanation. Right? That's how I read the claim. So from a kind of broadly physicsy point of view, you might say that what the determinable properties that feature in the fundamental level, right, that's something that we have no explanation for. Which determinants of those determinables are realized, that's again something of which we have no explanation, say which specific masses and charges say. The way that those determinate properties are arranged with respect to one another, the way that they're clustered together, for example, that's something that has no explanation. And so it's a kind of implicit in that what the fundamental natural kinds are, right? Whether the fundamental particles are electrons and protons and positrons or whatever it is, that's something of which we have no explanation. So if the fundamental particles turned out to be just electrons and positrons, we'd have no explanation of that. If it turned out to be the particles of the Standard Model plus 100 other particles, each like an electron, but that one has 1 unit of charge greater than the last or whatever, right? There would be no explanation of whatever it is that it in fact turns out to be. So it's that proposition regarding the fundamental natural kinds that I'm going to put front and center in my talk. And it's that implication of brutalism that I'm going to be taking issue with. So let's flag it up. Call this brutalism about fundamental natural kinds. So suppose that the fundamental kinds of this world are K1 to Kg. Let the set of those kinds be denoted Fk. Then that the set of fundamental kinds is Fk is a brute and inexplicable feature of the world, right? Something of which we have no explanation. Now, I'm going to take it as like a datum in going forward that since we don't yet take ourselves to have a fundamental theory, we make no claim at this point to know exactly what this set is. Okay, we don't know, we don't have made confident claims as to what exactly the set of fundamental kinds is right now. However, even though we don't yet know what the fundamental, or we make no claim to knowing exactly what the fundamental kinds are, you might think we've already got reason to be suspicious of brutalism, right? Even in advance of knowing precisely what these kinds are. So say you were to have a hunch along the following lines. So let's say that, so the Standard Model is our most fundamental theory we've managed to produce to date. Yet there's plenty of beyond the Standard Model theories that take, the leptons in there, the Higgs boson in there, not to be fundamental particles, to be composites of something else. So they might not be fundamental for all we know. Yet it remains that they are still the most fundamental particles that we've managed to discover to date. And plenty of those particles were predicted well in advance of us discovering them, right? So the latest example of this was the Higgs boson that was predicted like half a century ago and just discovered in 2012. So you might say that, well, you don't need to be a dogged adherent of the deductive nomological model of explanation to think that there's some intimate connection between prediction and explanation. And therefore you might say, well, it's not the case that the Higgs boson is just something brute and inexplicable by our lights, right? It's not something of which we have no explanation of why it exists, why it has the properties that it has, and so on and so forth. And so you might say, well, given that we've managed to secure this, right, have achieved this kind of explanation of the most fundamental particles that we've discovered till now, there's every reason to think that that kind of explanatory ability is going to persist into the future, right? There's no reason to think that we won't be able to predict the truly fundamental particles and hence give some kind of explanation of those too, right? We take physics to be getting better and better, after all, right? However, it's got to be said that if that's your best argument against brutalism, it's not clear how powerful it is. And the reason is that if you're a brutalist, then you think that there's a critical metaphysical distinction between the fundamental and the non-fundamental with respect to explanation. And therefore, if you're kind of open to the idea that the Higgs particle isn't fundamental, that it might not be fundamental for all you know, a brutalist is free to claim, well, it's not surprising then that you could explain it. What I'm saying is that because there's a difference, I'm postulating my whole position is predicated on a distinction between the fundamental and the non-fundamental with respect to explanation. So you can't use facts about what could be non-fundamental as some kind of inductive base for inferring anything about the truly fundamental. Okay. And it seems that indeed anything that we can say in advance of a fundamental theory or our possession of a fundamental theory that's kind of predicated on how physics has gone so far is just going to be open to that kind of objection from a brutalist. So, at this point, it maybe seems that if you want to deny brutalism, you really have to kind of sit on your hands. Seeing as brutalists are always able to make this move with regard to the history of physics, you're just going to have to sit on your hands until we have that fundamental theory. We have grounds to think that we know what the fundamental set is. Look at the kinds, see if we can give some explanation, and only then can we make an argument against brutalism. But if that's the case, then it would be bad news, right? Because that could be a really long time coming, assuming that it ever comes at all. However, what I want to claim is that that kind of pessimism is maybe unwarranted. All right, I want to claim that there might be something of a workaround here. So that is, I want to claim that it might be possible for us to deny brutalism even before we have a fundamental theory. For suppose that though we don't know what the fundamental natural kinds are, we nevertheless have some well-justified beliefs about what kind of physical objects those kinds are, whatever natural kinds they may be. Okay, so what am I talking about here? Well, to see what I mean, note that when I ask of what kinds the fundamental entities are, I'm speaking somewhat ambiguously. So I could be asking you about what natural kinds they are, right? Are they electrons, are they positrons, and so on and so forth. On the other hand, I could be asking about what kinds of object they are in a different sense. I could be asking you, are they the objects of classical physics, of quantum theory, of relativistic quantum theory, of string theory, and so on. So call these different types of objects in that sense different objectual kinds. So it seems to me that these are two very different ways of thinking about fundamental kinds. So the members of the first set differ in terms of their determinate physical properties. The second set, on the other hand, differ from one another in terms of more kind of overtly metaphysical features, such as whether all of their state-dependent determinate properties can be defined of them simultaneously, in terms of whether they enjoy identity over time, in terms of whether they exhibit ontological vagueness, in terms of whether they can be specified in a point-by-point manner, and so on and so forth. Okay. So different kinds of physical objects in that latter sense seem to differ in a more profound sense than an electron-positron differ. And of course, it seems that physics has over time counseled us that these are all different types of physical object, right? These are all kind of possible physical objects, if you like, right, as it has progressed, and as one revolution in thought has displaced another. Now, it seems to me that we can have grounds for thinking that the fundamental kinds are all of some objectual kinds without knowing what natural kinds they are. So those of you who are heavily invested in, say, string theory, even though you make no claim as to knowing, so string theory is a sort of framework for theories, even in advance of knowing precisely what the fundamental theory is, like what the fundamental particles are, what the fundamental law is, and so on and so forth, are probably going to say something like that. But note that none of this changes the fact that what the fundamental natural kinds are is taken to be a fundamental feature of reality, right? That's taken to be a fact about the fundamental level. Thus, it seems to me that if, after postulating that the fundamental kinds are objectual kinds of some particular sort, we find that we can thereby explain the natural kind structure, we'll have done something to explain the fundamental. And as a result, brutalism can be claimed to be untenable, right? And that is the case even though we did put in something about the fundamental by hand. So what my claim is what I'm going to argue going from this point on is that if we assume that the fundamental objectual kinds are quantum fields, then we can deny that what fundamental natural kinds there are is a brute and inexplicable feature of the world, right? In contradiction to brutalism. Now again, I've sort of said that this assumption is sort of likely a fiction on account of the absence of gravity from quantum field theory at the moment. Although I should say, so I pointed out to some of the people on the program, there is an active program called asymptotically safe gravity that tries to incorporate gravity into quantum field theory, and maybe some people on the project would like to look at that. Okay. But as I say, really, I'm using quantum field theory, the framework of quantum field theory, as a kind of a model for how explaining the fundamental might go. And I kind of leave it as an exercise for the reader to see how the metaphysical, methodological lessons generalize to a more realistic candidate of a truly fundamental framework. Okay. So I'm going to make a baseline assumption in going forward. I'm trying to argue against brutalism by making a kind of baseline assumption, right? That the fundamental kinds are kinds of quantum fields. That is, quantum systems defined on Minkowski spacetime. Okay, so those of you who are at all familiar with quantum field theory, or indeed quantum theories in general, will sort of know that the basic framework of a quantum theory doesn't, in general, sort of pin down uniquely exactly how to understand its basic ontology. But nevertheless, let's sort of pick an interpretation of quantum fields that will sort of serve to kind of clarify what one might mean by talking about quantum fields. And I'm going to pick the wave functional interpretation. Kind of because it's a more kind of intuitive sort of general, a more intuitive notion of a quantum field, if you have any familiarity with classical fields. So according to the wave functional interpretation of quantum fields, the state of a quantum field at any time is given by a functional. And what this functional is, so it's a function of functions, and what it does is it acts on classical field configurations, right? Any classical field configuration that's compatible with the boundary conditions of your problem, basically. And what it does is it acts on that classical field configuration, and it spits out a complex number. And the way that we're going to interpret this functional is by saying that the square of this complex number gives you the probability that if you were to go out and perform a measurement on this quantum field, then you would get that classical field back with that probability, right? Assuming you could sort of do a measurement at every point in space at that particular time. So that's how we're going to interpret what we mean by a quantum field. Now, I'm also going to make at this point, so sort of I don't know if this is an additional assumption, but probably it is, and I'm just going to really sort of flag up something quite explicitly. So what I'm going to assume sort of going forward is that quantum fields are sort of by their nature probabilistic entities. Okay, so what I mean by that is this. So let's suppose I'm postulating that the fundamental entities in this world are quantum fields. And what I'm saying when I say this is to say that if you were to take the actual fundamental fields and reduplicate them in another world, then in every world in which they occur, they are the sort of thing that entails that probabilities that certain probabilities can consistently be applied to a certain, they're the sort of thing that entails that probabilities can consistently be applied to a certain class of events, right? Namely, that that classical fields are going to be obtained upon a measurement, and moreover, that those probabilities can be obtained in accordance with the above recipe. Okay, so a quantum field is by nature probabilistic. In every world in which they occur, this is true of them. And so you might say, well, why are you making such heavy weather about this? Well, either you're saying, why are you making such heavy weather about this because it's just implicit in how you've defined them, or you might be saying, why are you making such a controversial non-Humean assumption? At least I think it's non-Humean. And the reason I'm being really explicit about this is because people like that guy there, Chris Refuting, has really been sort of putting pressure on me to sort of really been trying to convey to me that this is the sort of something that you need to assume in order for these kind of the arguments that I'm going to make, which are going to heavily rely on the requirement of consistency with unitarity. It's something like this kind of substantive metaphysical assumption that I have to make about a field in order for that kind of assumption to go through. And presumably, I'm not even entirely sure about this. If you kind of think harder about it, it's not entirely clear to me that Humeans really should have a problem with this. But certainly people of a Humean disposition have taken issue with it when I've talked about issues in this kind of ballpark before. So just let me say, the reason I'm assuming this, right, is because this claim about nature seems to be a necessary assumption of my argument. Maybe at the end we can talk about whether it is necessary. I can explain in more detail what the perceived problem with it is supposed to be, or what the problem would be if we didn't assume something like it. And as I've said, Humeans maybe won't like this assumption, but it's not my business today to argue against Humeanism. I'm going to make this sort of assumption and put it into my model of how fundamental explanation might go. But I really want to flag up at the outset that even if this is an explicitly non-Humean assumption, it does nothing to trivialize my claim that aspects of the fundamental can be explained. So often when you put in an explicitly non-Humean assumption, like a sample of radioactive material has a propensity such that for half of it to decay in a given time, Humeans say, haha, well, I can give you now an explanation of the frequency of certain events that Humeans can't. I have explanatory power that my theory has explanatory power that yours doesn't. And Humeans are going to say, well, that's a completely trivial explanation, right? And they presumably have a point there. But notice, I mean, if there's anything that I'm putting in by hand, it's something about the probabilities of certain events. But I'm not trying to explain an event. I'm trying to explain a natural kind structure, right? And that isn't an event. Okay, so there's nothing about this assumption that's going to trivialize my explanation. We can talk more about this at the end. Okay, so we've put in some of the basics. What do we know at this point about the members of the fundamental kind structure? Right, that's what we're trying to explain, don't forget. So we've basically put in by hand that they are quantum systems of Minkowski spacetime, they're quantum fields, right? This is going to set our baseline. Anything that we can explain from this point is going to count as a mark against brutalism. So the next thing that it seems like, putting that they are quantum systems with kind of probabilities sort of intrinsically kind of attached to them, or essentially attached to them, tells us something about the laws that the fundamental kinds obey, right? We don't know exactly what the laws are, but we know something about them. And we know that those laws have to be unitary. So why do we know that? Well, we know that because, so unitary evolution is norm-preserving evolution. So it's the kind of evolution that you need if you want to go from states, quantum states, such that the sum of the probabilities associated with every element of their sample space, right, every possible classical field on which they can be defined and on which you could obtain upon a measurement, sum up to 1. So unitary evolution takes you from states that have that property to other states that have that property. But being such that the sum of the probabilities attached to every element of your sample space, which is in this case, the sum of the probabilities attached to obtaining certain classical fields upon a measurement, sum up to 1, is just an axiom of probability theory. Okay, so it's something that is necessary for you, something that's necessary for you to be able to speak of having a probabilistic system at any time at all. Okay, so unitary evolution is evolution that takes you from states to which probability can consistently be applied to states to which probability can consistently be applied. And given that we're dealing with states, with systems whose nature, as I've said, is to satisfy, to be the sort of thing to which one can attach probabilities, it seems that the evolution has to satisfy this kind of constraint. Okay, and as I said, this is something like, so the unitarity constraint on a quantum theory is often regarded as the consistency condition. So it's spoken of as a special way, such that laws that violate unitarity aren't just empirically false or something like that. They're actually just incoherent, right? It's physical nonsense, given that you assume you're talking about a probabilistic system. So unitarity seems to have a sort of privileged status among the axioms of quantum theory. Okay, so where are we? We don't know we make no claim to knowing what the fundamental law is, but given the objectual kinds involved quantum fields, things to which we can talk that have probabilities attached to them, we know that the law respects the unitarity constraint. So what else do we know about this law? Well, it seems to me that we know that it's a law of interaction, right? We know this already. So either this is us putting in a little bit of empirical data in by hand here, right? Given that physics exists, given that things interact with things, there's interactions in the world, so presumably these interaction at the fundamental level. You may even want to go further and say that actually this is not just an empirical fact, this is a conceptual truth, right? And so what I mean here is that you could say if there was no interaction, there'd be no composition, there'd be very little in the way of scale dependence, there wouldn't be anything that really looked like a level structure at all. So if what it is for something to be fundamental is to stand in a privileged relation with respect to other ontology, it seems that you could claim that the existence of interactions is sort of necessary for anything to be privileged in that sense. I've kind of been playing around with that a little bit, but it doesn't matter if you buy that idea that it's somehow a priori, given that we want to talk about fundamental entities. But anyway, it seems that by hook or by crook, it seems at this point we know that. Well, we know that it's a law that's not superseded by another as we probe smaller and smaller scales, right? That's just part of what it means to be a fundamental law. It keeps working even as you look at smaller and smaller scales. And given that the framework, the arena in which we're working is Minkowski spacetime, i.e. a spacetime that doesn't bottom out into discrete sort of spacetime chunks, is rather such that spatiotemporal regions boil down to regions of measure zero. Given the complementarity between energy and momentum in quantum mechanics, this means that in this theory, energies can in principle grow arbitrarily high. So it seems then, what you mean by a fundamental law in this context is a law that is valid in the infinite energy limit. So while that in itself seems to be, that's just really what it means to be a fundamental law in the framework of quantum field theory, and it's pretty kind of easy to see why. While it's easy to derive that, it's also kind of relatively easy to see that respecting unitarity in this limit is an extraordinarily demanding requirement. And a priori, we would not expect any theory to actually satisfy it. So why is that? Well, the reason for this, technically in quantum field theory, is because in this framework, the interaction couplings become functions of the energy. So your Hamiltonians, right, that are going to describe your laws of nature are obviously functions of the interaction couplings, or functions of, right, which are kind of the things that tell you how strong your interactions are. Those couplings are in turn functions of the energy. Right, now if I said to you, right, I have got a function in a drawer here, it is a function of certain variables, I'm going to let those variables shoot off to infinity. How would you bet if I asked you that that function is well defined? Well, you'd be pretty well advised to bet that the function is not well defined as its variables shoot off to infinity, right? It's a very special class of functions that are convergent in a limit like that. So generically, we can expect a Hamiltonian, right, through this chain of reasoning to just be the sort of thing that is not well defined, that kind of shoots up to infinity, right, in the infinite energy limit. And it's pretty easy to see then that the predictions of a theory, right, the empirical predictions that that Hamiltonian implies are not going to respect unitarity. So for example, suppose we take the probability of producing the Higgs boson, given that we smash two protons together, in the Large Hadron Collider, to be given by a function that looks like this. If the bit in the middle, the Hamiltonian, has shot up to infinity, then that guy certainly isn't going to be finite either. And as such, it's certainly not going to be some number less than or equal to 1, okay, which is what unitarity would require. So obviously, there's a lot more to say about that and the details of the mathematics. But the bottom line is that really, a priori, only very special Hamiltonians would be expected to respect unitarity in the infinite energy limit, right? Given that the interaction couplings, as I say, have this feature of changing with the energy. So we can say, well, what Hamiltonians have the property of respecting unitarity in this limit? Well, at a minimum, we know they're those whose couplings stay finite in that kind of limit. So which Hamiltonians have that property? Well, here we have no results that are both nice and general and also sort of interestingly specific, sadly. So what we do know in general is that it's going to be a function of, whatever the answer is here, it's going to be a function of the field content of the theory. And the reason for that is that the way that that the couplings change with the energy is described by something called the beta function associated with that coupling, the beta functions of the theory. And what we know about those beta functions is that they're a function of the spin and the mass of every field that features in the theory. Okay, so whether this thing is going to be well behaved in the limit or not, whether the coupling is going to be well behaved in the limit or not, is going to be a function somehow of the field content of the theory, what fields you have hanging around. Now, can we say anything more specific than that? Well, we know precisely what the nature of these constraints is only in a special case of fundamental theories. And there are those theories whose couplings not only stay finite, but that actually disappear in the limit. Okay, and these theories we call the asymptotically free theories. Okay, now clearly this is what I'm going to assume to go on, right, just for the next couple of slides, is that the asymptotically free theories and the fundamental theories in quantum field theory, right, boil down to the same thing. Now obviously this isn't true, because there's a lot more ways for a theory to be finite than for a coupling to be finite than for it to go to zero. In the limit. But I'm going to assume this for now, and just as I kind of finish up this section, I'll sort of say why it doesn't really matter, right? I'll just ease the presentation. Okay, so I said we have some specific results in the case of these theories. So what are these results? Well, we know that in order to be asymptotically free, one condition is that non-abelian gauge bosons have to feature in the theory. So this is something that was proven by Coleman and Gross in 1973, and what was essentially like a proof by cases. So what they did is they said, right, we've got some examples of asymptotically free theories, like QCD at that point, I think. All of them feature non-abelian gauge bosons. Is this an accident? And what they said was, let's suppose that they contained only fermions, or let's suppose that they contained only spinless bosons, or let's suppose that they contained only fermions and spinless bosons, right? Would those theories be asymptotically free? And they showed that they wouldn't. Okay, so it seems that containing non-abelian gauge bosons is a necessary condition on asymptotic freedom. The second result that's of interest here is that in order to be asymptotically free, there are limitations on the number of fermions that can feature in your theory. So the earliest example I know of somebody sort of showing this is in Gross and Volchek in 1973, but maybe some of you know of an earlier reference. But anyway, a couple of years later, Sidney Coleman summed up the situation as follows. theories of non-abelian gauge fields and Fermi multiplets, i.e. fermions, are sometimes asymptotically free and sometimes not. If the theory of contains too many fermions, the sign of the beta function is reversed and asymptotic freedom is lost. So what is the significance of this? Well, the significance is this. So what we know is that there are some non-fundamental theories that contain only fermions, right? Such as the early Fermi theory of the weak interaction. Now, these can be perfectly good as effective theories, perfectly good as describing non-fundamental portions of reality. But what, at least to a good approximation, which is good enough. But what Coleman and Gross show is that theories like that are not candidates for being fundamental theories, right? You've got to have some gauge boson in there as well. Similarly, take a theory that we know at the moment is asymptotically free, namely QCD. Now, it turns out that a theory with an SU3 a theory with local SU3 gauge symmetry is not always just guaranteed to be asymptotically free, because it turns out, and it's actually not too hard to show this, that if we were to discover another 10 kind of quarks, right, another 10 sort of species of strongly interacting fermion, maybe in the LHC, then the asymptotic freedom of this theory would be lost. It's only asymptotically free if there are 16 or fewer species of fermion in the theory. So it seems then that we can say that the fundamental kinds, right, whatever the fundamental kind structure of the world is subject to something that I call the Goldilocks principle. So presumably we know that the fundamental theory contains matter fields, right? It contains fermions of some sort. But we know that that can't be all that exists. There have to exist some other particles as well, namely some non-abelian gauge bosons. But similarly, we also know that there can't be too many fermions, right? At least if we're, again, taking fundamental theories to be coextensive with asymptotically free theories, because then the asymptotic freedom would be lost. So just to flag that up in a little bit more detail, it seems that whatever the fundamental kind structure is subject to the Goldilocks principle. So that is, whatever this structure is, it will take the following form. So there will be bosons, there will be fermions, right? The number of bosons is some positive integer. I think if you were looking a little bit harder at the symmetry structure here, I'm pretty sure that that integer would have to be greater than or equal to 3. There's going to be some fermions, but there's an upper limit on how many fermions there could exist. Again, we're not going to go through too much maths here, but it shouldn't come as too much of a surprise to hear that what these numbers are going to be related, right? The fact that there are 8 bosons in QCD is intimately related to the fact that you're only allowed up to 16 species of fermion. Okay, so that's whatever the natural kind structure takes. If it's a fundamental theory modulo or qualification, which I'll come back to in a moment, we know that it has this kind of a structure. So, a couple of points to note before we move on to the last section. So, it seems that many, right, indeed in the last analysis, when we really put in the numbers here and think about how intimately the numbers of fermions and bosons are related, it seems that most sets of kinds are not going to conform to the Goldilocks principle, right? To see this, right, there are infinitely many different possible species of fermion, right? But there's got to be finitely many, a small number of fermions in that fundamental kind structure. So most arbitrary sets of kinds that you could just put together a priori are not going to be compatible with this principle. Nevertheless, although it is a non-trivial principle, imposing compatibility with the Goldilocks principle does not pin down the fundamental kind structure uniquely. So we could take QCD, suppose that's the fundamental theory, we could add 1, 2, 3, 4, 5, really anything up to 10 additional fermions, and it could still be a candidate for a fundamental theory. So it doesn't pin it down uniquely, but it is a really strong constraint. Okay, so what about just going back to this idea that, so my claim that whatever the fundamental kind structure is, it's subject to the Goldilocks principle, this assumed that the fundamental theory is an asymptotically free theory. And we said that assumption is not warranted. However, I just want to emphasize that we can still expect something like the Goldilocks principle to be true in the more general case of asymptotic safety. Okay, so while we don't know in the general case precisely how the matter content has to be tuned in order to preserve asymptotic safety, we know that it has to be tuned somehow. We know that the field content can't be arbitrary because the behavior of your beta functions is going to be determined by the field content of the theory. So in each case, we might say that the treatments will be different, but the underlying disease is the same. Okay, so something analogous to the Goldilocks principle is going to hold. in the more general case. Oh, this is broken now. It's broken. It doesn't work anymore.
Oh. Try that.
Okay. Thank you. Okay, so that, if you like, was the kind of quantum field theory sort of background. Now to get into my claim, right? I'm claiming that there's something, right, in the Goldilocks principle, right, that suggests that brutalism about fundamental kinds is just wrong. So let's remind ourselves just briefly, what did brutalism about kinds say? So it says, suppose that the fundamental kinds are whatever they are, k1 to kj. We don't make no claim to know. Let this set be denoted fk. Then that the set of fundamental kinds is that set is just a brute and inexplicable feature of the world, right? And that I'm going to claim is false. Now, how am I going to argue this? Well, the first thing that's got to be said is that how to go about this argument, right, is not immediately obvious, right? How you would back up that particular claim. And the reason it's not obvious how you deny brutalism here is because the sort of explanation that is afoot here is itself not obvious, right? And as such, it's not like there's just going to be some obvious, well-articulated, extant body of literature that I can go and look at, say, oh, this is the theory that most people think is effective. I can just apply that in this case, and lo and behold, it shows that the fundamental kinds can be explained to some degree. It doesn't seem to be like that. It's not clear what kind of explanation is afoot here right off the bat. So one thing in particular is clear, that it's not causal explanation that's the right, appropriate kind of explanation here. I'm not trying to explain some event in terms of an earlier event. I'm trying to explain a natural kind structure. That's not an event. Similarly, it seems it's not grounding explanation, right, that metaphysicians are very interested in, particularly at the moment, it seems. And the reason we can say it's not grounding explanation is because grounding explanation, by definition, relates less to more fundamental levels. And here I'm at the most fundamental level, right? There's nowhere further down for it to go in order for it to be explained. Okay, so it's not obvious what kind of explanations afoot. And since, the former is often called scientific explanation, especially in the metaphysics literature, and the latter is often called metaphysical explanation, seeing as we're trying to do the metaphysics of science, right, it's not clear, right, what other kinds of explanation that is that we should be looking at, thinking about, and trying to apply here. However, what does seem plausible is that some kind of mathematical explanation is afoot here. And the reason we say that is because it seemed clear that consistency considerations, consistency with the principles of probability in a certain mathematical limit, was played a really indispensable role, it seems, in the previous argument. So at least we have that. Nevertheless, I'm going to take as my starting point, not looking just at the literature on explanation, on mathematical explanation, I'm going to take as a starting point some early work in causal explanation. And in particular, what I'm going to look at is Meller's modal account of explanation. Modal account of causal explanation. So this account, so this was kind of part of a kind of cluster of papers that were trying to, give license to philosophers, or philosophers of science were trying to kind of allow scientists to say that they had an explanation for certain events, after the advent of quantum mechanics, in which those events didn't follow with deductive certainty. But we want to say, right, these are not all just brute facts, right? So it's trying to give explanations, allow for explanation in the absence of deductive certainty. So this paper his contribution here, was motivated by the thesis that a good explanation raises or makes high its explanandum's probability. And the more it does so, ceteris paribus, the better it is, right? So that's the basic idea. Now, what prompted this was a general thesis about explanation, according to which we call for explanation only of what, although we know it is so, might have been otherwise for all else of some suitable sort that we know, whether there's a gap, that is, between what is and what must be. Okay, so that's the thesis, and that's what inspires it. So why am I using this as my starting point? Well, it begins with intuitions that seem nicely general. This is supposed to apply to explanation in general. And seeing as we're not entirely sure what kind of explanations involved here, that seems to be a good thing. Moreover, the notion of probability raising, if explanation is going to track facts about probability raising, that seems nicely neutral on whatever processes, mechanisms, properties, whatever it is that's involved in the raising of probability. And seeing as we don't know the nature of what's doing the explaining here, that also seems like a nice thing. I might say that something like this enjoys a bit of contemporary support, sort of Michael Strevens has defended an idea broadly like it. And moreover, and what's going to be crucial for our purposes, is the explanation here is deliberately designed so as to sanction indeterministic explanation. Okay. So just to say a little bit more about that here, just to put a bit of flesh on the bones. So according to Mellor, ideally, an explanation closes the gap between what is and what must be altogether, right? So what you want to explain is something that you know, but you don't know why it had to be the case. Ideally, when you provide the exponans, then you do know why it had to be the case, because it follows with sort of deductive certainty. Sometimes, however, he says such an explanation is not to be had. An event may lack sufficient causes, as radioactive decay does. In all these cases, what happened might not have happened. For all we can learn of the prescribed prospective causes, we cannot, in the prescribed terms, close the gap that calls for causal explanation. But perhaps we can narrow it. The epistemic possibility of an exponandum's falsehood comes by degrees, and relative probability I take to be the measure of it. So gaps that causal explanation would close completely may be partly closed by probabilistic explanation. That indeed I take to be its purpose. So what I claim now is that we can marshal this notion of partial closure against brutalism about the fundamental kind structure. Okay, so just to see how this is going to go. So Mellor's general thesis tells us that if we want to explain P, we need to show why P and not Q, where Q expresses what might have been otherwise for all else of some suitable sort that we know. Right, so he says when you're giving an explanation, you presume a background of relevant common knowledge, right, with your interlocutor. So let's call Q, the thing that could have been otherwise for all else that you know at this point, right, call Q the foil. Now, in order to explain fully, you need to rule out every single candidate foil. However, according to Mellor, if you can rule out some, then you have a partial explanation of what you seek to explain, and the more you rule out, the better. Now, given that I've said I understand brutalism to be the claim that there's no aspect of the fundamental level that has any explanation. So what I'm going to claim is that if we even have a partial explanation of the fundamental kind structure, then it can't be said to be brute. So it's going to follow that we can deny brutalism if we can say why the fundamental kind structure is that set, whatever it is, and not some other set, right, an arbitrary set, let's call this NK, so long as it could have been that arbitrary set for all else of some suitable sort that we know. So the question is, well, what else do we know? Well, we know what we explicitly put in by hand, right, where we set the baseline. We know that the kinds involved are quantum fields of some sort. Modular interpretation that these are intrinsically probabilistic entities in some sense. So at that point, right, at our starting point, before I embarked on the explanation, we know that it seems that the candidate files are just arbitrary sets of quantum fields. Right, we're trying to explain why this set and not another set. At that point, it's like it could be any old set of fields. Arbitrary sets of fields are on the table at that point. So we then sort of ground through the argument, and we saw that considerations of the consistency constraints on a probabilistic theory, and that should be in the infinite energy limit, right? These mathematical constraints show that most of these sets are not actually consistent. Most of those arbitrary sets are not consistent with the Goldilocks principle. Hence, they are not consistent with being fundamental. We nevertheless saw that whatever the actual fundamental kind structure is, it doesn't seem to be unique in being so consistent. And so, putting everything together, it seems that Mellor's strategy implies that we have a partial explanation of the fundamental kind structure, whatever it is. Okay? And so it seems that we're home and hosed. But of course, it's not quite as simple as that. Because it's not as if Mellor's strategy, a probability-raising strategy, is without its critics. And the most obvious criticism, right, the criticism that's screaming to be made here, is that you might say that modal explanation is too weak, right? Because explanation is by its nature hyper-intentional, right? Which is just one way, it's just a fancy way of saying that it transcends merely modal information. So this objection has been made all sorts of times in the literature, so you can see the kind of Hempel and the Shadow sort of criticisms of that as being kind of expressions of that sort of point of view. Similarly, it seems to be, the purely modal account of explanation seems to be untenable, given that we recognize that there could be explanation in mathematics. Right, so you might know with deductive certainty that Gödel's theorem is true, right, given things that seem to you as being incontrovertible. And yet you might still want to say, I have absolutely no idea what it is about the natural numbers that explains why Gödel's theorem is true. I know that it's true, I know that it's necessarily true, but I have no idea why. And there's no room for that on a purely modal account of explanation. And indeed, it seems that Miller himself is just insensitive to these kind of considerations. So this is what he says in the paper. His thesis is supported by explaining why explanation features less in logic and mathematics than it does in history and science. To know something in logic and mathematics is mostly to just have proved it, and so to know that it could not have been otherwise. There is not the gap between knowledge of what is and what must be that calls forth explanation to close it. Where there is, as perhaps with Fermat's last theorem, a proof would indeed explain. Right, and people who think that there is room, like some proofs are explanatory and some not, are just going to directly deny this. In fact, people, so since he wrote this, right, Fermat's last theorem has been proved. And some people disagree about this, but some people think it's not explanatory, right, because it should have been proved in number theory to be explanatory, something like that. So in order to go forward, just to close up, I want to emphasize as best I can, and I'm sort of still working on this, that my argument hasn't just shown that certain candidates are ruled out. It's given what looks like an explanation of why they're ruled out. Okay, it's not just, I'm not just showing that something's the case, I'm explaining why it's the case. So let's have a look, just to quickly recapitulate the argument, and I'm almost done. So what did we look, this is, you can't really see the numbers here, but this is a sort of recapitulation of the argument. So we said that the fundamental entities are quantum fields. This was a stipulation I put in by hand. I made a metaphysical claim about quantum fields, that is, that they're by nature, their nature probabilistic. In any world in which they occur, they're the sort of thing that implies probabilities for certain classical measurement outcomes. We said that the fundamental level is one in which fundamental kinds interact in accordance with laws, right? Either this was a conceptual claim, or maybe, or at the very least, a kind of minimal empirical, bit of empirical input. We said that fundamental laws are laws that are valid in the infinite energy limit. That's just part of what you mean by a fundamental law in the context of quantum field theory. We said that laws are probabilistic systems, where probabilities associated with a kind of Born rule type recipe have to be unitary, right? Again, that just seems to be required, a consistency constraint on talking about a probabilistic system so defined at all. We said that laws featuring just an arbitrary set that we just pulled off the street are not going to be unitary in the high energy limit, right? That was shown by Coleman and Gross in their proof by cases. Therefore, putting 2, 4, 5, and 6, I guess you can't see them anyway, together, an arbitrary set, assuming that's not consistent with the Goldilocks principle, is not going to be a set that features in the fundamental laws, and therefore we can confidently say that that isn't the natural kind structure. Okay, QED. Now let's just look again at that argument. Look at the second premise in particular. So here I've made a claim. Quantum fields are by their nature probabilistic. Right, now that seems so, part of what, that seems to be an explicitly metaphysical claim, right? It's making a claim about what the nature of certain entities is, which is just the hallmarks of a metaphysical claim. And moreover, the hallmark of a metaphysical argument is one that tries to sustain its conclusion by appeal to metaphysical natures. Right, so it seems that my argument has some components that look like the sort of things that you would find in a metaphysical explanation. Similarly, premise 6 there about how the laws that feature an arbitrary set behave in the high energy limit, the thing that was proven by Coleman and Gross. Well, what makes this true seems to be facts about mathematical functions. Right, this can't be made true by facts about physical systems because it's a proof, it's a kind of impossibility proof, right, showing that there's no physical system that satisfies this. So it's made true by facts about the nature and structure of mathematical functions. But it's mathematical explanations are arguments that explicitly appeal to things like the nature and structure of mathematical entities. So again, my argument has sort of has elements that look like the sort of the elements that you find in a mathematical explanation. And therefore it seems to me that we've got grounds for thinking that my explanation overall has elements of a mathematical explanation and a metaphysical explanation, right? And as such, it is in itself, has the character of an explanation. And of course, that it has that sort of metaphysical, it's an admixture, if you like, of metaphysical explanation and mathematical explanation, seems to be completely appropriate in a way. Like me, you think of physics as some kind of admixture of the mathematical with the metaphysical. So that all seems to work for me. Okay, so pretty much done. Let's just flag up a few criticisms of the argument before I wrap up. So one of these we've already met. And this is that quantum field theory is, in all likelihood, not a fundamental framework, right? And I said, okay, I'm happy with that, but I'm going to place a bet on the general metaphysical and methodological morals that the fundamental can be explained in through something like this strategy, in particular by thinking about the consistency constraints on theories, on fundamental theories. I think that's going to transfer to more realistic candidates of fundamental frameworks. Indeed, I think it's going to be made even more pronounced, simply because as you go to more and more fundamental frameworks, the constraints get stronger and stronger and stronger. And so I think that what the natural kind structure is likely to be pinned down more and more uniquely. That's just a bet. So some people, and I've given this argument, something like this argument sort of before, people have objected to just putting in the conclusion by hand by assuming something about the fundamental kinds. And then using that to explain something. Well, I am putting something in by hand, but I don't think that this means I'm putting the conclusion in by hand. It's, as I said, it's still the case that what the fundamental natural kinds are is a fundamental feature of reality. It may not be the only feature, but it is one. And therefore, if you can give some explanation of that, I'm not claiming that we can explain every feature of the fundamental level. In particular, I'm not claiming that we can give an explanation of why the fundamental entities are quantum fields. But if I can explain something about the fundamental level, then brutalism just doesn't seem to be tenable. And moreover, even though the arguments seem to, and again, this is where my thinking is sort of going, and I'm still working on this, but if by making an assumption that quantum fields have a kind of intrinsically probabilistic nature, if that's an explicitly non-Humean assumption, it's not one that trivializes my explanation in the way that sometimes putting a non-Humean assumption in can trivialize explanations, as I already explained. Now, this last criticism I actually think is the most interesting in a way, and this is that a metaphysician might ask, no, brutalism is still there, because the kind of explanation that you have given me is not the kind of explanation that I'm interested in metaphysics, right? The only kind of explanation that I'm interested in metaphysics is maybe something like grounding explanation. So I can plug in my fingers in my ears and not listen to your argument. This is not a sort of explanation that's relevant to me. And indeed, there's a kind of worry here, because Van Frassen has obviously argued that whether something counts as an explanation is a very interest-dependent claim in general. And I don't know anything about this guy, that somebody Farbach argued in this paper about brute facts, that whether something is brute can depend on your interest. So for example, a car accident might count as a brute fact from the point of view of a psychologist, right? There was nothing about the psychological state of the drivers involved that made the accident happen, but maybe not if you're a civil engineer, okay? Or a car manufacturer. Maybe it's not a brute fact then. So again, this is where my thought is kind of going and trying to think about this. But I sort of want to deny this, right? This looks to me like just denying my conclusion by stipulation. After all, components of my explanation look overtly metaphysical. If making explicit appeal to the nature of fundamental entities doesn't make something a metaphysical explanation, I'd like to know what does. Furthermore, these days metaphysics is seen as increasingly about the fundamental. Wherefore, it's about something that is of central interest to metaphysicians. Right, so there's some explanation that can be given of their most important, their most critical kind of subject matter. Right, should really it shouldn't be the sort of thing that they can say, oh, I don't need to worry about that to cure. Anyway, more to say there. A final note. What can we say? So it seems that physics and metaphysics have completely orthogonal views with respect to whether the fundamental can be explained. Where does this issue from? Right? Well, where's this kind of disconnect come from? Well, I'm not going to try and explain this. I'm just going to put a thought on the table that's been with me for a long time. So I'm just going to quote Mark Steiner. Philosophers have long pondered explanation in the natural sciences. If they have ignored it in the mathematical sciences, blame lies perhaps with a lingering distinction between matters of fact and relations among ideas, the corollary being that mathematics, belonging to the latter class, has nothing to explain. Now, Now, what I think has really kind of gone awry here with metaphysics is what often goes awry with metaphysics, and that it sort of forgets, when thinking about physical ontology, it forgets the kind of Galilean insight that the book of nature is written in mathematical characters. It seems to me that the objects of physics have natures that you can only express through mathematics. And when you pretend that you can think about things like recombination and modal structure and what the possibility space of the world is only in terms of well-formed formulas of the predicate calculus that basically any idiot can write down, and forget that an arbitrary mathematical function is a priori not going to be well defined in the kind of limits that matter to you when you're thinking about the fundamental, it shouldn't come as a surprise to find that you can't explain anything, at least if you think explanation has any kind of a modal element to it at all, even if it's not the whole of explanation. So that's there for, remind me to say thanks. So thanks.
So I want to, I guess I have a worry that about the explanation being the kind of explanation that the brutalist sort of means when she says that the world is, that the fundamental theory is just proof, or the fundamental ontology is proof. So, like, suppose my house gets broken into, and I look through and see what was stolen, and I see, oh look, TV's, my TV was stolen, my electronics were stolen, must be a burglar who's after my electronics, or something like that, right? And it turns out I'm right, but there was a burglar who's after my electronics, but it just happens that this burglar was just, without any cause at all, spawned 24 hours beforehand with the desire to rob my house and steal my TVs, and just soon enough to plan out the burglary and to do it. So if that were the case, I'm thinking about, this is like a brute burglar, okay? I can give an explanation of, why I lost my TVs and electronics, and I can even reason to the fact that it was a burglar, but it doesn't seem like I've given any kind of explanation of the burglar himself in that case. It seems like I've just, used what follows from the fact that there was a burglar there. I've reasoned back to who the burglar was. And so in your case, it seems like the brutalist is looking for, maybe I'm missing something here, but it seems like what the brutalist would be looking for is, why is it that quantum fields are the fundamental thing? And they would say, there is no explanation for that. And that's what I mean by brutalism.
Okay, sure. Well, note that if, in order to give an explanation, every aspect of your explanation itself needs an explanation, then there would be no explanation of the non-fundamental, according to the metaphysician, but precisely they think that there is an explanation of the non-fundamental.
In terms of the fundamental? Right? Is the idea.
Yeah.
So is the brutalist going to deny that? I wouldn't think so.
So what I'm saying is that we've taken certain facts as brute, and we've managed to explain other facts that belong to the fundamental level. So there are certain fundamental features of the world that do have an explanation. I'm not claiming that everything can be explained, but I'm saying that there are some fundamental facts that we can explain. And that is in contradiction with brutalism.
So it seemed like the explanations that you were talking about were all explanations reasoning sort of backwards from things that follow from the brute facts, or the fundamental facts.
Yeah, but they're also fundamental facts. They're facts about what is in the fundamental level. So
you're reasoning two facts about the fundamental.
Yeah, so it's a kind of, it has a kind of horizontal sort of a character. It would need to, because there's no more fundamental things for it to be explained in terms of, so there's going to have to be some kind of horizontal character to it. But that doesn't do anything to contradict the claim that there are fundamental features of the world for which we have given some explanation.
So in each case, you're reasoning from the non-fundamental to the fundamental, right?
No, I'm reasoning from things like consistency constraints on a fundamental theory. So, like I said, there's there are kind of elements in there of, things like, well, we know it's a law of interaction because then we find interaction sort of around us. And I'm trying to, at the moment, I'm playing around with the question that you can actually, given what you mean by something being fundamental, maybe that could become a kind of conceptual sort of claim. But it seems that there's that sort of minimal element, empirical element pertaining to the non-fundamental that I've sort of put in. Hopefully that's seen as kind of rather kind of innocuous. But yeah, so I'm not my claim is not that I can explain everything about the fundamental. I can explain every fundamental fact. I'm saying there are some fundamental facts that I can explain, and that, as I'm saying, is enough to contradict sort of brutalism, right? That the fundamental is by definition brute and inexplicable. Because I mean, that kind of assumption does a lot of work in metaphysics. So it's used, for example, as an argument for recombination of fundamental properties. They don't have an explanation. They're not dependent on anything else. They're wholly independent of everything else. So you can recombine them, and so on and so forth. So it's an assumption that does a lot of substantive work in metaphysics. So it's not as if metaphysicians can say, well, because you've got this horizontal explanation, it's not the kind of explanation that I care about, because actually you appeal to it a lot of the time in your own arguments. The idea that there's no explanation, and in particular, no explanation of the sort that I'm saying is actually present.
So, right. So okay. So that helped me. So the brutalist really thinks all the fundamental stuff is not to be explained. And your point is, in particular, some facts about what the fundamental natural kinds are can be explained. Yeah. And so brutalism in general isn't true, even though some things will turn out to be true.
So brutalism is not the thesis that there are brute facts. Right? Brutalism is the thesis that if something is fundamental, then it has no explanation.
I'm going to put Chris on, if that's okay. Did you hear the question? Was the volume okay for the question?
It was kind of difficult to hear it, and I sort of understood it, but it's hard to follow everything in detail.
Okay, go ahead.
Okay, so I guess my worry for most parts of the talk were well summarized in your third objection, like in the previous slide here. The complaint that really what people like Schaffer and Cameron and other metaphysicians who make claims like this mean when they talk about the explanation really is a metaphysical explanation of a grounding kind, the sort of the explanation, in virtue of type of an explanation. Not that I myself want to defend that, but I think that's what they have in mind. And so I suspect that they wouldn't really be moved much by you coming up saying that, oh look, there's some fundamental facts which are explained in the sense of Meller's probabilistic explanation by other fundamental facts. Therefore, your brutalism must be wrong, because they would really just say that this is not an appropriate kind of explanation. It looks more like the traditional deductive homological type of explanation. If you predict something, you're able to sort of constrain something by bringing to bear other facts. So in that sense, it's not perhaps fully a prediction, but it's a constraining way of getting to something. And it's true that some of the metaphysical facts that we use to explain other metaphysical facts, fundamental facts, are of the metaphysical kind, or metaphysical facts. But I think that doesn't make the explanation appropriately metaphysical in the sense that these people may insist it should be.
Okay.
So, so even though there's a lot of metaphysics assumed and part of the explanation, the structure of the explanation, or the fact that it is an explanation, is not of the appropriately metaphysical kind.
Okay, so I agree with you when you predict what it is that metaphysicians would do, but what I'm interested in is what they should do. Right? And okay, and so what I'm saying, if you can't say this is not a kind of explanation that it... Pardon me?
What do you say to these metaphysicians in response?
So, you can't say that the kind of explanation that you are interested in is by definition grounding explanation, right? You can't just say that, because I'm free to ask you why. And then I get a story about how grounding is a distinctive kind of metaphysical explanation, and what makes it metaphysical, what makes it the kind of explanation that metaphysicians are interested in, is because it makes direct appeal from natures. It's a kind of explanation that proceeds from the natures of things to other things, and that's what my explanation does too.
Okay.
And moreover, moreover, it's not like these guys don't think that explanation has to be sort of constrained by logical sort of considerations. And I'm just saying, well, there's another set of logical considerations, mathematically expressed, mathematical logical considerations that are missing from your explanation. And moreover, I think we can go with Steiner as well. Look, there are no entities of a more, the study of the nature of mathematical entities is as metaphysical a kind of project as you could think of. And I think, so Steiner is just absolutely right here. That, insofar as metaphysicians sort of neglect how facts about mathematics pertain to the world, it's just that's to metaphysics loss. So again, so these claims about what I predict that they would do, I know what they would do, they'll dig in their heels, they'll ignore me, all that stuff, I predict. But there's a question of making a normative claim.
Yeah, so presumably what they have in mind is something like, well, a grounding explanation is an explanation that it explains facts in terms of more fundamental facts.
Yeah, but obviously that's not
if that's
inappropriate.
what you say, then you're really begging the question.
Yeah, no, exactly. Well, obviously that's a priori not a kind of explanation that would be appropriate here, but that's the only kind of explanation that has the hallmarks of metaphysical explanation that could be deployed here.
Okay.
Nick? Kerry, can I ask a clarificatory question about the distinction between natural and objectual? So the examples you gave of natural were things like electrons, positrons, photons. And how did you mean for us to pick these out? So are these picked out mathematically?
No, just in terms of their the normal sort of metaphysical sort of view, where they're just like a kind of cluster of determinate physical properties.
And this is supposed to be what metaphysicians take natural kinds to be.
Yeah.
Right. Right. And by the objectual kinds, you meant the determinables are determinants.
No. So the determinables of which these would be, well, it depends.
So
What, depends what you
an
mean.
example, right? So instead of saying, to go with your example about constrained particle content, we're not just talking about particle content. I guess we're also talking about field content, really, right?
Yeah, but.
So the things that are being constrained are the number of fermionic fields. We're also constraining what kinds of spins the fields have, what kinds of determinate fields there are.
What, through
So
an argument, to making an appeal to quantum field theory?
Yeah.
Oh yeah, no, that's another aspect of that we could, if we wanted to, we could have said we can explain other features about the natural kind structure.
Right, yeah, those things fall under natural kind structure.
What things?
So-
What?
Spin one field,
Yeah.
right? It would fall under natural kind structure.
Yeah.
Okay. And okay, good. Thanks. That's helpful. So I don't know this metaphysics. I don't really read the people who talk about grounding. I have trouble getting inside their heads. But something you can imagine someone saying is, look, when I'm talking about brute objects, I don't really think an object is fully specified, unless you also tell me all sorts of relational structures in which the object is embedded.
I think metaphysicians are not going to say that.
You don't think they're going to say that?
No.
Okay,
If you say that, then you're
you can
thinking
see the
like a
direction
physicist.
now. Yeah. But this kind of remark, because someone thinks this.
So, yeah,
Then-
sorry, I've interrupted you.
Yeah. So, on this view of things, right? Look, you don't know really about the object's dynamics. To say that, if what it means to specify an object also includes dynamics. And dynamics in two senses, both at a scale, but also between scales. Then you're going to end up with a view that's, very close to your view. You can say that, you can rearrange the content of the object in various ways. You can talk about the kinematic thing itself, but you also talk about the dynamical laws in which it's implicated, so interpret it very broadly. Right? So dynamical laws includes Lagrangians and the origin flow that takes one to the other.
Okay, I can assure you that this is not what you're going to hear from a metaphysician.
Yeah.
Right.
But
So-
it's at least a possible line, right?
Okay.
It's and it seems natural I mean, so it seems silly to try to insist that an object should be specified so barely. Right.
I mean, I agree.
Yeah.
But I don't see how that counts against the argument. So, if by natural kind you think that we should have, so this determinate determinable language, so there are some natural kinds of quantum field theory electrons and classical electrons and string theory electrons or something like that.
Yeah.
That wouldn't-
Look.
so absolutely then you are right away, you've walked into the argument.
Right, but that's right. So the thought isn't that this harms the argument against a very naive brute fundamentalist.
Okay, that is also the brute fundamentalist. These are coextensive for
Right.
most of the.
Okay.
Yeah.
Okay. So the thought is, look, there is this fallback position, this weakened position
Mhm.
that the brute fundamentalist can go to, where he says roughly what I just said, right? And the question is, what would you say to such a person? So is this still something you want to attack? Or is this something you no longer really have a problem with?
Well, when you said that the natural kinds are some kind of quantum field, so that's part of what I mean by natural kind, then we can just run the whole argument and say, well then what precisely the natural kinds are is not a brute inexplicable fact. It follows from the same considerations that they're subject to whatever the kind structure is, it's subject to the Goldilocks principle.
Right.
It just comes in a little bit, it just sort of takes two steps of the argument and kind of collapses them into one.
But part of this weakening of the position is, I mean, a correlate of weakening the position in this way is that you're not going to try to claim that everything is brute, right?
No.
That's the way I'm envisioning the position.
My position?
So, no. The position of the metaphysician who's going to weaken.
No, but they do claim that everything's brute. That's what it is to be fundamental.
Right, so I'm trying to describe a weakened fundamentalism, and what I want to know is, so do you just have a problem with people who say everything's brute, or?
Yeah, that's the position I'm taking on.
Okay, what would you say about people who weaken the position?
To some things are brute.
Some things are brute?
Yeah,
Maybe
that's the
even
but that's the position that I'm basically defending, right?
A lot of things are brute, right?
Some things are brute,
Yeah.
but that's not the position that I was attacking. The
Okay.
position that I was attacking was that a position that identified the fundamental with that which had no explanation. I'm saying that that's untenable, even though it's completely reflexive. Like these kind of statements that I put up at the beginning are just, the kind of bread and butter of metaphysics, and I find it very jarring, and I've tried to explain why. And so I'm not saying that there are no brute facts.
Why do you think metaphysicians are unwilling to say that in order to specify the objects, you also have to look at the structure of relationships implicated in, for instance, dynamical laws?
Well, because that is to kind of endorse a position that's stronger than the one that I am. I mean, I'm saying that it's possible for different kinds to feature in different laws up to a point. So it would be stronger than what I need. Why make
so
it?
you could weaken it, right? So you could say, up to a level of specificity. So we can talk about different levels of specificity at which we want to describe objects.
Look, I'm kind of sympathetic with the idea that until you've given me a framework, are we talking about classical physics, are we talking about quantum physics, are we talking about field theory? Until we have that, then the possibility space hasn't been sort of put on the table.
Sure.
So you might go that kind of Kanapian kind of, pardon me?
We can certainly take QFT as an example.
Yeah.
You can run this on.
Yeah, so basically, I still don't see how to making the kind of move that you said, but before you can even talk about a kind, you need to specify a framework. When I'm saying, right, there's kinds and there's frameworks, and I'm going to assume that's right. So it kind of comes to the same thing. But I wouldn't want to say that the only way you can identify a kind is in terms of the law that it features in, because I think that electrons can feature in different laws.
So in the position of envisioning, it's not the only way, but it's part of how you understand what it is to be what you call an objectual kind, right?
Yeah.
And that's at least part of what it is to be a natural kind.
Yeah, sure. So the two
Yeah.
steps of the argument are just conflated into one. I mean, I agree with you, but
Okay.
I'm also trying to speak metaphysicians' language.
Right.
That they think of a natural kind as just a concatenation. So again, it's an understanding of the natural kind, of a natural kind that is a kind of hangover for, like, I think there's something about thinking about the metaphysics of thinking about metaphysics, so thinking about physical theories in terms of things you can express in the predicate calculus, which just sort of cries out for a substance, a kind of substance attribute type predication, and doesn't understand that, you know, physics has given us different notions of substances, if you like, different ways that objects can be,
Right.
even if they have the same determinate properties.
Right.
Yeah.
Okay, good. Thanks. That's very helpful. One just quick last observation, which is that this style of argument seems to be used in many places in physics, in fact, in quite disparate fields, and it's even used to constrain objectual kinds, not just natural kinds.
I don't.
Right?
Yeah.
So, what are?
Do you have an example? What
Sure.
example do you have?
So,
in
for
mind?
instance, trying to pick out quantum theory, right? So you run the argument. So here, in what Kerry said, the desiderata is, well, the thing you put in by hand is that it's a probabilistic theory, and you want to preserve unitarity,
Yeah.
right? So maybe in the example you're trying to pick out quantum theory, the thing you're putting in by hand, you're looking at different kinds of information, right? So information is now going to be
Okay.
at the level of your objects.
All right, sorry, I thought you meant something else. I thought you meant that there's only certain, finding a framework that is the sort of thing that could describe something that seems like a physical system is itself highly sort of constrained, but that's a kind of meta-level set of constraints. There's some people who argue that maybe the guys you were talking about, that string theory really is the only candidate. When you think about what physics is and what you want out of it, physics is something like string theory is the only candidate thing that we've managed to think of that looks like a fundamental framework.
So that's
Right.
definitely in the same general spirit, right?
Yeah.
Except this kind of, I guess, that's much less worked out than.
Yeah, no, absolutely. So that's why I
Yeah.
kind of just picked that bit, and then
Right.
somebody
Good,
else
good.
can kind of make the argument about how even that case that putting in by hand that the quantum fields, it's not clear how much freedom you had there in the first place. Do you know, it's like some people have defended that there's no way that classical physics could describe the fundamental level of the world. People have certainly sort of made that claim, even before you think about empirical considerations why we threw it out. But there's just when you actually think about the paradoxes of contact and action at a distance and blah blah blah, there's just no way that. So people would try and sort of make that claim at the meta level, but they're going to be correspondingly because it's not constrained by a physical framework. It's going to be that much more tenuous at that level.
I'm going to try the mic in another place to see if this. Thanks for everyone's patience. It's still a bit of an experiment. Try to point your head a little bit at the microphone when you're speaking to make sure. It's fairly directional out the front here. So, but I think if you're close enough on the side that it'll be okay. Yes, please.
My question is related with Father Raphael's question. So, just to make sure, you agree that if I try to explain, let's say, why the table is like this. I mean, if I try to say, look, the entities should be this, like this or like that, so that the table looks like this. Like if you start with the results, with empirical results, like certain restrictions. I mean, empirical results give you certain restrictions of what entities should be there. Right. But if you say these are the entities because we have these empirical results, then I know that would be like circular or.
Yeah, sure. So you would just be conditionalizing it on some consequences or something.
Yeah, sure.
Yeah, sure. But I think all I put in was this really minimal thing that there's interactions.
Sorry?
The only empirical input that I think that I put in was that there are interactions.
Okay.
It's a bit of empirical, and that just seems like
Yeah.
kind of
Yeah.
not such a big deal. I mean, I appreciate kind of the last analysis of the argument. I wouldn't want to. I just don't. I wouldn't want to be the one to have to explain why there are interactions in the world.
Yeah.
Okay. So.
And that there are laws.
Well, if there are going to be interactions without laws, it's not that we're putting
Sure,
laws
I'm just saying that's part of the...
Oh yeah, so that's, yeah. But...
That's part of it.
Yeah.
I'm
That
sorry.
stuff interacts.
Actually, I have two questions. Would you? I mean, I think you don't have problem accepting like someone who says laws are primitive or something like that, or
I haven't taken a metaphysical stance with respect to the relative priority of laws to some other category.
yeah, I mean, your account it's compatible with someone saying natural laws are primitive, like, right? Or
Yeah, I don't see
Yeah.
why not. Yeah.
Are there more questions in Geneva, Chris?
Just maybe one remark, if I may.
Okay, go ahead.
So you looked at the case of quantum fields of Minkowski space-time that propagate according to unitary dynamic
Yeah.
laws as an example of fundamental physical theory. And of course, as you will not be surprised to hear, I think pretty much none of these aspects will be present in a fundamental theory.
In a
But-
fundamental quantum field theory.
But let me, I completely agree with you that I think we have very good reasons to believe that similar considerations will apply, similar explanations of constraining things in terms of other fundamental facts. Fundamental facts in terms of other fundamental facts should be expected to still be present. So I don't think that. So I completely agree with you that the general lesson here is very likely to translate to more fundamental physics.
Okay, great.
Go ahead.
Would you be amenable to saying that this argument?
Could you speak up just-
Oh, yes. Would you be amenable to saying that this argument can pass for example, Newtonian gravity? Right? If you said something like the universe is classical and we have absolute space and our objects are volumes in absolute space. And because absolute space is three-dimensional, you can reason back and say that the objectual kinds can't have more than three spatial dimensions or something like this.
So, I mean, this is kind of an interesting point. So I kind of want to say that, so this is where I really sort of worry that people want explanation to be metaphysics. I think this is where there's going to be a more sort of substantive comment for metaphysics. They want explanation to be some kind of relation in the world, whereas explanation is something that happens for a subject, right, an epistemic subject. And the less obvious a conclusion is, we don't take things that are sort of immediately obvious to us to be the sort of things that need explanation, and therefore the sort of things that kind of have explanations that of the sort that we're interested in. So you might say, well, the postulate. So it seems that is there more room for sort of saying? So you can postulate that space is three-dimensional, and then you can explain something about the properties of objects. And yeah, I appreciate there's not going to be a sharp line between what explanations are sort of trivial and what explanations are interesting. Don't forget that even if you're a fundamentalist, it's not like you think that there are no facts about the world that you could explain at all. But you can sort of explain why there are no round squares in the fundamental level or something like that. So exactly where people draw the lines about what kind of explanations are interesting and which kind of explanations are trivial is something that's kind of up for grabs. But it certainly strikes me that this is an explicit claim that people have said is a fundamental. This is something that people have said is something of which there is no explanation, and I've said that there is an explanation. So it kind of been obvious that there is an explanation. So hopefully this is at least information in the kind of conclusion. But yeah, how to sort of draw the line here between what's an interesting explanation and what's not, I don't know. But I also know that metaphysicians don't tend to articulate what the rules of the game are, kind of either. So to take another example here, so see if I can explain this. So people say that, you know, if you take something like Lewis's sort of Humanism seriously, then you have complete moral freedom of how things can be recombined. But it seems that you haven't got total moral freedom as to how things can be recombined. Right? You don't let it be the case that an RT2 predicate or a property or two-place property can change places with a four-place property. That's not something that you allow. You don't allow objects and properties to change places with one another. You don't allow a monadic or a three-place relation to change places with space and time. Like these all sorts of things that are kind of structuring. There's all these sort of rules that you don't tinker with in order to make claims about what's possible and what's necessary and so on and so forth. And until you've set up some kind of a moral framework, you can't say what sort of things can be are possibilities, what sort of things are ruled out, and therefore what sort of things need explanation. So to kind of go back to your point, yeah, I mean, I think that absolutely. If you're going to talk about possibility, it's pretty clear that there's at least some relation, even if it's a more fine-grained relation than a modal relation. There's some close relationship between explanation and one's theory of modality. In all cases, we assume a certain framework, and metaphysicians take a certain framework, like Lewisians take a certain framework as sort of sacrosanct, quantum field theorists take a certain framework as sacrosanct. If you can show that something, well, anyway, so there's always, one is always taking something for granted. And people tend not to be explicit about what it is that they're taking for granted, because we all like to fancy ourselves as not taking anything for granted, right? So I think that's something that's just, maybe explains what's going on, and I think that your point sort of reminds us of.
Is this the kind of thing you were thinking of? I mean, if one was to think about the Newtonian case, and it's not just the kinds of like material objects that we think of are in the natural kinds, but the forces as well. I mean, like Kant and people did try to run this argument about the three-dimensionality giving us the 1/r². And that has the same, I mean, it doesn't really work, but if it did work, it would have the same kind of character. And it doesn't seem that it fails because gravity, the 1/r² is brute and therefore can't be explained. That's not why it doesn't work. So that's the kind of thing. Yeah. Okay, so you would see. So,
this is getting back to what explanations are interesting. It seems like that's a hard question, but it sort of seems to me like explanations about about what would be consistent aren't very interesting. In that, I mean, wouldn't the brutalist concede that yes, it's a brute fact, but it couldn't have turned out to be something inconsistent? I mean, I would think a brutalist would readily agree to that, and that wouldn't be. I don't know. I guess I'm struggling with do we have an explanation for these fundamental facts? If all we can say is, well, there couldn't have been an inconsistent combination of these facts. Does that make them not brute? Because we know they couldn't have been inconsistent?
Yeah, so they have. So this is the way I'm wondering. So presumably, they would say I have an explanation of why the fundamental level doesn't have something that's both red and green all over, or something like that.
Yeah.
And I guess part of what I'm asking people to take on is that there's a whole other raft of consistency considerations that you're not taking into account. And moreover, these are consistency considerations that allow us to say not only why it's not some inconsistent way, but why it's really positively is the way that it is. I mean, so maybe these sort of not a distinction there, but I guess part of what I'm doing is saying that there's a whole raft of consistency constraints embedded in physics, like I'm saying at the end with respect to Mark Steiner, that make it the case that facts that you took to be brute have an explanation.
So is it then that there's a different kind of inconsistency rather than just the sort of in-your-face conceptual inconsistency of?
So I think that's kind of what I mean. So we call for explanation, like he says, of things that don't strike us as obvious.
Yeah.
And modal standard Lewisian sort of modal metaphysicians sort of put in by hand things about that they take to be obvious and don't sort of need mention. But this example that I gave of Fraser McBride about actually the thought like they don't allow properties to, they allow them to sort of change roles, but it's not like they can take on sort of different arities right? So that's just something, a kind of background assumption that they just completely take for granted and regard as needing no explanation. Like, because it's just obvious. And there are certain things that are going to be sort of obvious to a physicist. So this is the thing, like, you know, there's an explanation for things that could strike us as being able to be, could be being otherwise. And, you know, when you're in a more privileged epistemic position, that won't be the case that that doesn't need explanation for you anymore. But it's not that it doesn't have an explanation, it's just that it doesn't need one because it's obvious to you now. So, insofar as, yeah, I think consistency considerations can explain a hell of a lot. I think they do a huge amount of work. I think mathematical consistency does, I mean, it does almost no work in metaphysics because it's like math doesn't exist. At least not as a sort of predicate of physical entities or concrete entities. But when we do that, we see that when we remember that actually it is a constraint, then all of a sudden things come to be ruled out. It's just that they weren't a priori, because it wasn't a priori obvious, it seems as noteworthy and it seems as something that we need an explanation for. So I think with the consistency constraints, yeah, there is explanation. Maybe this kind of goes back to your point, you know, with the regular case, you know, so a regular metaphysician could say, well, I can explain why the world isn't inconsistent, why the fundamental level doesn't exhibit inconsistent properties, but there's sort of, it's too obvious, it's a sort of need pointing out, it's an explanation that's sort of, it's too trivial, right, to warrant. So this is where I think, so this part of what I'm trying to do with this talk is to sort of realize that this talk, something is root and inexplicable, right, there's a whole continuum of sorts of things you could mean. They're partial explanation, or it seems that there are some things that are explainable, but they're not obvious. So it just seems that this whole kind of language of bruteness is just so kind of clunky and sort of ham-fisted, and, you know, we need a much more, I think, sophisticated talk about what's going on, explanation at the fundamental level. And it seems that physicists have got a much more sophisticated story to tell about why things are the way that they are. And you know, I think it's something that metaphysicians should aspire to. So.
Sure. Let me go back to Chris's question about quantum gravity and this thing happening in UV completions in general. And so one example you gave was asymptotic safety, right? And so, do you think of, so let's go to a string theory case. Do you think of constraining the critical dimension by means of anomaly cancellation as fitting into the kind of schema that you discussed?
I don't know anything about string theory.
Well, yeah. Maybe Nick,
Yeah, well,
you think?
yeah, that sounds like the same thing.
It's because it sounds like the same thing to me.
The consistency of the theory requires the 26 dimensions.
And
for the
precisely in
bosonic.
this case, unitarity.
Right.
And it's unitarity that's doing the work there too.
So if you
That's what we're getting.
yeah
Okay.
That's
have a gauge anomaly, then typically you lose unitarity.
But yeah, it talks in that in quantum field theory, but not in string theory. So again, I mean, presumably if you're coming from working in that sort of framework, you know, it's just a brute fact that space is this out of that dimension. It could have been so many other things, and you guys are just like, well, that just doesn't sound right at all. And again, this is taking place in the context of physicalism. Like I said, this is this other orthodox sort of point of view that the fundamental level is going to be described by physics. Right? So it seems to me if you want to try and say, if you're willing to say that A, you're a physicalist, and B, that the fundamental level is brute, then you should be willing to, you know, the fact that physicists don't find that the features that you point to in the fundamental level is brute, well, presumably that's information, right? That ought to be factored into your position. But I'm glad to hear that it becomes even more pronounced in string theory. That's what I thought.
Yeah, but I mean, anomaly calculation. I mean, I don't think it affects the kinds of fields you can have in quantum field theory, but the ways they can couple is affected by this, just an ordinary quantum field theory.
Well, you need to have, let's see.
The anomalies are caused by the kinds of couplings you have rather than the kinds of particles you have.
Well, you need to have fermions to even have anomalies in standard QFT, right?
Right.
Yeah. So you need gauge theories coupled to fermions. Those are the kinds of theories that have anomalies.
Right.
Yeah. So they don't just generically arise in like scalar field theories.
But they don't prevent you having fermions. They prevent the fermions coupling to the bosonic fields in certain ways.
Yeah. Good.
So it's at the interaction rather than the kinds of things.
Oh, really?
I can talk, yeah. Can I ask, we're nearly out of time, and I guess I wanted to finish up. So you started motivating this with a quotation from Weinberg,
Yeah.
right, about the aim of physics at most fundamental is not to describe, but to... So do you think he'd be satisfied with this? Is this what he had in mind for the kind of... So how does he lie up? I mean, is he going to say, no, this is still too brutal, I want a real physics explanation?
It's too brutal. Yeah. Yeah, they want to explain it all, but that's going to require some kind of explanation at the level of picking one framework over another, and it just strikes me that it's not like I don't think that can be done, but it's so much less clear what the rules of the games are. You have such a bird's eye view on physics because by definition it's not constrained within a physical framework. It's just going to be that much more. You're going to be groping around that sort of much more.
So this was 92, where he's probably thinking quantum gravity, string theory is the only way the only thing that's going to work. He probably doesn't think that anymore.
Yeah, but I mean, I think he's kind of objecting to this sort of view that it seems to follow from this sort of brutalist picture of the world, in which sort of explanation goes down to the bottom and then it just stops. That fundamental physics is essentially just an empirical science. You're just reporting on what you find there.
Right.
This just seems like really just not the way that any kind of anybody who's come into contact with these theories is going to think about them.
Is this from the QFT book or
No,
from
that's
Dreams of a
the
Final
one,
Theory?
that one, the Dreams of a Final Theory.
So he must be partly talking about a kind of old-fashioned, very positivistic picture of science as just a catalogue of empirical facts, kind of.
No.
This really is about brutalism.
This is it's about the hope of denying brutalism and the hope, and I think in an even more profound sense than I've said that we can kind of pull off right now.
Yeah. Well, we said we'd finish at by 11, so we're about there now. Are there any more questions from Geneva? Are there some brutalists in the room who want to...
No, the physicians are out of town, unfortunately.
I expect they were just too scared, Chris.
No, and they are out of town for a legitimate reason. So.
Yeah. Okay, well, let's say thank you. That was great. Thanks so much.